Good morning, everybody. Thank you all for taking the time to come and listen to this presentation today. I hope we'll be able to tell you something interesting and that you might be able to take back and utilize to make your businesses more effective. So I'm going to kick off by a quick introduction on what we're going to cover today. We're all gathered here today because the industry sees a massive opportunity around battery and EV production, and along with that, there are a number of new challenges that are being presented to the industry that need to be solved over the coming years. But in addition to those challenges are many new opportunities to implement new manufacturing best practices and leverage high degrees of automation and flexibility in your production processes. And so as Industry 4.0 takes shape, we as a business, we see some major trends forming across the industry. And it's these that we'll use as a backdrop for our discussion today. So for volume assembly, we see many manufacturers moving away from pure conveyor-based lines and investing significantly in AGV-driven or AGV-borne work in process. We also see high degrees of automation in the production logistics space coming on board through the use of AGVs, as well as significant investments in IoT. And there's a lot of attention going into artificial intelligence at the moment as well. We also see increased tooling flexibility. So many manufacturers are starting to invest heavily into cordless battery-powered tools because of the flexibility capabilities that they offer. And we also see the convergence of IT and OT, enabling data-rich shop floor processes and increased levels of quality assurance down on the shop floor. So along with those benefits, we also see the challenges that some of these new capabilities present. And so with AGV-borne WIP, for example, we see that idle time can be high because operators in many cases can be sitting waiting for AGVs to arrive at their destination before they can actually start their work. If you're investing heavily in cordless tooling, error-proofing of those processes, those tooling processes, suddenly becomes a much more challenging task, as operators now have the freedom to move between workspaces and along with the traveling work in process. And when you're bringing data down onto the shop floor, it needs to be context relevant to support optimal process execution, particularly with new and evolving workforces around EV and battery production. So this presentation today is going to be focused on how do you achieve or address these challenges. So we're going to start by talking about the technological inputs that are required to help you achieve these aims. And then we're going to talk about how these inputs can actually help you solve those real-world problems. And we're going to look at some real-world use cases. And then we'll end off by talking about how our experience of working with some of the leading names in the automotive industry and how they've evolved to the point that they are today by utilizing these technologies. And to that point, why should you listen to us? So we've actually been working with, as I said, some of the biggest names in the automotive industry for a long time now. And we're now working closely with those manufacturers on their journey as they pivot towards EV production. And so what we're going to talk about today is the sum of our experience in the industry of deploying these technologies over a long period of time and seeing what a significant impact they can have on the kinds of challenges that we'll talk about. So when we start talking about key inputs, key enablers, one of the most fundamental enablers is to build a real-time digital twin of your production process. And when we talk about a digital twin at UBsense, we mean more than the traditional kind of IoT view of the digital twin. So while connected systems gathering data off of your machines, your robotic systems, is vital to a rich real-time digital twin, there is a significant amount of information that's missing from that model of your facility. Because many of the processes, and many of the processes we'll talk about today, they are acted out by people down on the shop floor. And people are involved because there's a lot of movement, there's a lot of interaction, and there's a lot of dependencies between those moving actors, if you like, in the process to make your finished product come together. And what that means is your digital twin also needs a way of modeling and describing those moving and manual processes. And that means you need to be able to accurately model the geometric properties of your facility, model those actors in the process, give those actors and those assets that are moving around spatial properties, and also the ability to describe how you expect those items and actors to be interacting with each other. And only when your model allows you to describe that level of richness can you really bring your digital twin of your manufacturing facility to life. And so this is a really key building block in being able to address some of these core challenges. So where do customers, where we're working with customers, where do we see some of the stumbling blocks around these capabilities? So as I've said, one of the key things is to think bigger than just instrumenting fixed machines and robots. It's about being able to gather all that important data about your moving processes and the moving and manual parts in your EV assembly processes. And the other really key ingredient to an effective digital twin is it needs to be highly configurable. Your processes are adapting and changing rapidly over time, particularly as you're ramping up production and learning how to do things in the most effective way. And your digital twin needs to be similarly flexible and reconfigurable to adapt over time to your understanding of what processes should look like, and as you bring in new capabilities onto the shop floor as well. The second really vital building block, once you've got your digital twin capability in place, is just like your own human brain needs sensors to understand what's happening out in the real world, your digital twin needs sensing capabilities also to be able to reach out and touch all these moving processes and gather data from them. And that means you need the ability to work with a spectrum of location and identification sensing technologies. And the reason you need to be able to work with a spectrum is there's no one best sensing technology for all use cases. You've always got to consider the cost versus performance versus scalability balance. And so being able to pick one or a number of different technologies to support you in particular use cases is a vital ingredient. And we're going to see some of that later today as well. So customers who are embarking on these journeys, one of the key failure modes is trying to pick one sensing technology that can cover all use cases. And if you try to do that, you can get yourself locked into specific vendors, and then you've got limited options for broadening out the sets of use cases you can address with these technologies and with your digital twin. Also, getting blinded by the science and focusing on the wrong measures of success. Many customers are focused on the accuracy components of what technologies can do. And really it's the reliability angle to consistently meet the data requirements for your use case and for your digital twin is a much better measure of what's important. The third of our four key ingredients is you need a technology platform that tightly integrates with your production control landscape. business system integration is really key to populating your digital twin to enrich it with all the information it needs to properly model your processes, to properly model your production planning and your underlying process definitions. And in addition to data exchange with your existing business systems, you also need to be able to talk to all of those production control systems, everything from your tooling systems to your PLCs that are operating down on the shop floor where the rubber hits the road. And so you need a technology that can talk up and talk down and is completely flexible through configuration. And that means that you can continuously use the same underlying core technology to talk to existing and new systems that you're bringing into your processes. And so we see customers struggle here when they get seduced by the latest rip and replace solutions and not really focusing on ways to connect and utilizing their existing systems and making the most out of the data that they've already got in their production processes. We also see customers trying to make processes fit the limitations of the system that they've invested in, rather than defining their desired and optimal process and making the system support that. And our fourth key ingredient to success is being able to share data, not just with business systems, but with people. People are major consumers of data inside your digital twin down on the shop floor. And so the way that people consume data is through a broad array of human-machine interfaces that help them see only the data they need for the job that they're doing right now. And this is what we mean by context-relevant HMIs. And so you need a technology that is flexible enough to configure user interfaces that are applicable right now to that person's job and can again adapt with you over time as your processes change and evolve. And so we see customers struggle here trying to use legacy technology where HMIs really just the underlying technology is not flexible enough to evolve and adapt to the changes in process over time. And we see HMIs, the use of HMIs not be as effective as possible because they're not fully integrated into the whole process. And therefore they only provide a snapshot of the relevant data that's key to decision making for operators and personnel on the shop floor. So we're now going to talk about a couple of real examples of flexible production methods that are already in use today, using these technologies, these inputs that we've just described, that are well suited to the rapidly growing and evolving EV assembly process. So firstly, we're going to talk about modular production cells, and the digital twin enabler around modular production cells is software-defined workstations. We're then going to talk about control and error-proofing of wireless assembly tools and devices. And we're going to talk about automated and dynamic work instructions. And when you bring all those capabilities together, what you also want is the ability to implement digital process audits and better support any required rework operations across those new and complex products that you are now focusing on building. So we'll start by talking about a shift in the industry. And we've talked about AGVs, but one of the really key places that AGVs are starting to take hold is a change in the traditional assembly line layout. And there's a lot of discussion and written work right now about how manufacturers are moving away from that traditional assembly line towards more flexible and digitally connected modular production cells. And as I said, the key enabler to moving away from the line, but also still having predictably carried WIP through your process is moving to AGV-borne WIP. And AGVs provide a significant benefit in terms of how you can structure your flows of WIP through your facility. But one of the challenges that we see customers face when they move towards AGVs is if you look at this basic depiction of a line segment, we've got AGVs moving down a line, and we've got operators in what you might call traditional workstations or work cells waiting to do their work. An AGV-borne WIP will transport WIP from station to station, but the travel time or the speed with which AGVs can move is pretty slow in comparison to the overall cycle time or takt time that your WIP might spend in process. And what we see when the AGV transitions from station to station, the operators spend a lot of time waiting for the AGV to become stationary again before they can actually start work on the next product that's arrived in their station. And that's partly the speed is very much driven by the worker safety aspect of AGVs. And the wait time is because AGVs need to hit a known read point in station. Usually that's because there's an RFID tag embedded in the floor, and that identification is used to then reconfigure tools and other devices that are going to be used by the operator to execute those processes. And so on high volume lines, for example, where we're seeing many stations configured like this, we're seeing customers suffering up to 20% idle time for operators to wait for that AGV to become stationary in the station. So what's the solution to this? So a better way is to utilize that digital twin capability we were talking about before. So with a real-time digital twin of the entire line, remember we've completely represented all of these moving actors and processes in our digital twin, all of our tools. Moving processes can be completely digitized, and those interactions between products and workstations can be completely described in software. So now, as soon as the assembly transitions into the next station, the software-defined zone that we have around the station can detect that entry of the WIP into that station, and that can be used as a digital trigger that can be used to generate a control signal and reconfigure the work cell and enable any of the required tooling as soon as the WIP enters the station. Now operators are completely free to begin work on the assembly, even while it's still moving into station, because we know which piece of WIP has entered that station, and the digital twin is continuously monitoring the interaction of that tool with the product and its presence in that workstation. As soon as it goes out, we can implement other control signals to determine what is and isn't allowed to happen with that tool. And this same strategy can be used to initiate many other line-side systems as well. So the next key theme that we see is around battery-powered cordless nut runners. These are becoming the tool of choice for many OEMs. But with that improved flexibility for both usage and the other really key benefit of cordless tooling is around line rebalancing. Dropping the tether makes battery-powered tools a central strategy for flexible manufacturing in the new world of EV production. But with that enhanced flexibility, OEMs must maintain quality, and they need to ensure that operators are working on the right fasteners, on the right product, and in the right workstation, and everything is conforming to plan. And this is where, again, your traditional manufacturing systems don't have the eyes and ears, if you like, to see exactly what's happening with all those moving processes on the shop floor. And this is, again, where your digital twin becomes a key enabler for controlling these kinds of processes. So again, we turn to our digital twin. In this case, we create software-defined spaces like you saw in the last use case, but now rather than being static software-defined spaces, these are spaces that are actually attached to the product as it moves around in the facility. And now any time that a tool or any other device actually that moves in and out of these spaces that's defined around the product, wherever the product is in the facility, we can use those interactions between those spaces, as you can see depicted in this picture here, for various kinds of real-time process control. So one of the simplest use cases we see for customers who have got cordless tooling is they just want to make sure that the cordless tool is only being used in the specific workstation or around the specific vehicle that they've been assigned to. And this is what you might call a digital tether capability for just enabling and disabling tools with some basic rules. But over and above that, customers can use this capability as a real-time identification trigger and control space for tools, and they can use that for reconfiguring things like torque settings, batch sizes, reconfiguring the job on the tool, all in real time. And if you think beyond that, you can do things like sequence enforcement for tightenings. Here you can see multiple spaces defined around the product, and you can enforce which zone the tool is being used in around the vehicle or around the product, and in what sequence that's allowed to happen. And we're even seeing customers using this technology to break away from the traditional workstation-bound processes and supporting out-of-station working and even using this for online rework. So the way that this technology comes to life on the shop floor is through a sequence of steps in our digital twin, using those core building blocks that we saw before. So fundamental for your digital twin to know what's happening on the shop floor is, again, having that sensing capability to, in this case, know very precisely where your tools are located. And so one of the fundamental inputs to a tool control capability like this is having high precision location through typically an ultra-wideband real-time location system, because ultra-wideband provides you with the accuracy and the reliability in tough industrial environments. Your digital twin is then the key ingredient to converting a fire hose of location data from your real-time location system into a small number of structured events that are meaningful at a process level. And again, this is where our spatial definitions of our products and the zones and things that we're trying to monitor around them turn location data into structured interaction events. And once we have those interaction events, those are the events that we want to use to control the process. And your digital twin, again, through those integration capabilities we talked about before, needs to be able to communicate that out either to an existing manufacturing execution system, which will then interpret those interaction events and then turn those into control messages back to your tool controller. But your digital twin also can integrate seamlessly with any other existing infrastructure you have in place. So the same control signals can be used and sent directly to line-side station PCs. And your digital twin can communicate directly with the tool controller itself. So again, it's a very, very adaptable technology to fit into your existing landscape for generating these control messages for your tools. And then your tool controller then interprets that control message and sends the appropriate message to the cordless tool to either turn on, turn off, change batch setting, change torque setting, or all the necessary control messages that you would expect. So some of our customers, they're looking for the next level down as well. So in addition to being able to do zone-based sequence control, some of our customers are really interested in getting down to bolt level identification on the line. And in this case, again, your digital twin comes to the rescue by supporting sensor fusion capabilities, where you can combine best of breed sensing technologies to get to that really granular level of understanding. And in this case, we're talking about combining high precision location, like we saw in the previous slide, along with a vision capability. And so your high precision location allows you to register your tool in a particular location around a particular product. And then vision capabilities that are actually mounted onto the tool monitoring the tool head and which fasteners you're working on right now, that vision capability is then again integrated tightly with your digital twin to do a real-time recognition of the bolt or the fastener that you're working on. And again, that recognition works through your digital twin to decide whether that is or isn't the fastener that you should be working on right now. And you can do really, really clever things like granular sequence control around an assembly for what fasteners you are and aren't allowed to work on. And so what you can see here is we're bringing in different sensing capabilities. Again, don't get locked into thinking one sensor is the best sensor for a job. You need to be able to work with multiple different technologies. And your digital twin is the hub through which all of this data gets processed and converted into meaningful control messages for your systems. So in this next example, we're going to talk about bringing all of those capabilities together. So we're seeing, in addition to a big focus on AGVs, kitting is becoming more and more prevalent in the industry. And we see kitting and AGVs being combined together because they can help to increase productivity and flexibility, particularly around manual assembly operations. So in this case that we're going to talk about, sub-assemblies and associated kits travel via the AGV to manned workstations. So here we're talking about a particular example of the actual battery assembly process. And operators at each of those workstations, they perform a combination of part fitting, tooling processes, rundowns on fasteners, and they also perform inspection activities. And running like this, manufacturers can have multiple parallel workstations and routing paths that allow sub-assemblies to be built in any workstation. There's no specific workstation that an AGV has to go to for a particular build. And that means that manufacturers benefit from the ability to respond to demand increases across different model variants and incur no downtime because there's no line reconfiguration anymore. It's all done in software. Now, that approach in itself presents a number of new production challenges. So you've now got many, many different control systems and data sources that need to be tightly integrated to ensure process integrity and reliability. Going back to our input on integration being of high importance. We're dynamically changing operator process, and that requires everywhere that you are implementing a process, reliable product identification at all stages. And so having a low-cost way of deploying, basically through software, product ID anywhere in your process makes it much easier to design these kinds of processes. Now you're handling multiple model variants, and that means operators need to be guided with specific work instructions. And we also need to support operators with process error proofing. No matter what route the AGV takes in the process and which AGV arrives in front of them right now, we need to enable them to be able to perform the tasks for that particular model variant at that stage in the process. And so with this level of complexity, we also want to enable digital process traceability and audit, because that's going to be key for, there's always going to be an element of rework in these kinds of processes. That's just, the name of the game. So we want to be able to effectively support rework. And we also want to gather all the data about what's been happening over time so we can support process optimization, and we've got a rich record for compliance. And that means to implement this kind of a solution, there's a number of key inputs, again, that can be supported through our digital twin. So the beginning of the workflow is all about kitting control. So we actually want to build the right kit for that subassembly that's going to then go onto the AGV and head downstream for the assembly operations. And our digital twin can support that kind of kitting control. We've talked about the importance of flexible identification everywhere. We also need to be able to display those dynamic work instructions to our operators. And so we need, again, going back to our inputs, a really flexible way of displaying work instructions and other kinds of HMIs that are going to support their processes down the line. We've talked about precision tool control. And the other piece of this is the ability to gather all of the data off of those tools and other devices that are being used in the assembly process so that we've got that rich audit of what's happened on the shop floor. So digital process audit is a really key input. And as we've said, that audit is what's also going to help us to do effective rework support across the, to do finishing and completion of these products at the end of the assembly process. So if we look at those as against the backdrop of our digital twin and the capabilities that we've talked about, number one, we need to be able to do flexible product identification everywhere. And what you can see in the background here is a snapshot out of your digital twin that shows you all of those software-defined spaces or zones that you've got defined in your facility where you want to identify product. And the beauty of this approach is that you can create new identification points on the fly just by drawing them in software, or you can move them in software by the click of a mouse. We also want the ability to give context-relevant work instructions to our operators. And again, with the right kind of digital twin technology, that's as simple as putting up browser-based user interfaces anywhere in your facility, reconfiguring them on the fly. These kinds of configurations are done by our customers. You don't need to necessarily bring in outside resources to do your own HMI configuration. And that becomes a really powerful tool to support things like Visual Factory, getting the right data to the right people at the right time. We've talked about bringing in all of your tooling operations and precision tightening control. And this is particularly important around these kinds of battery assembly operations. In addition to tooling, we also want to be able to integrate with other devices like barcode scanners, passive RFID readers. All of these devices, again, that we talked about earlier, are through your digital twins integration paths, allow you to gather all that data in one place. And when operators are completing their processes, you want to be able to gather your tightening data as well as all those other process completion points that they are doing, and gather that into one full audit of the process. And so that history of your process can then be replayed. It can be used to support your rework operations. What is wrong with particular products that have gone through that process right now? Shortages is another key challenge that customers face. So you're able to see all of that data in one place. And over and above supporting completion of the product, that historical view is also there to support continuous improvement over time. And there's a rich body of data upon which you can do analytics as well. So we've seen a number of key technologies today. And what is hopefully clear is that adopting a digital twin platform strategy like we've shown here today will prepare you to be a digital enterprise of the future. These technologies help get you on the roadmap to solving multiple EV production challenges, and that's all with the same core technology and approach. And this journey and investing in these capabilities will really help to create a step change in your assembly processes and make your processes as smart as the products that you're actually producing down on your shop floor. So thank you very much for listening to me today, and I welcome any questions.
Super. Thanks so much, John. Indeed, it is time for the Q&A portion of this webinar. If you'd like to ask a question, but you haven't yet done so, go ahead and type it into the Q&A box on your screen, and we'll try to get to as many as possible in the time we have left. I've already got a few questions come in now, John, and we'll start with some of those. Someone asks, how long does it take to implement a solution like this?
So that's a great question. And as you can see, there's a number of moving components required to bring a solution like this together. So, we typically see projects break down into two key streams, if you like. One is around the deployment of the sensing technologies that you're going to use to support giving your digital twin the eyes onto the shop floor. And so those kinds of projects, we see small projects where the deployment of your sensing capability can take, a couple of months. Whereas, sometimes we're deploying capabilities across an entire assembly line. Here we're talking about several kilometers of assembly line in some big factories. And those kinds of projects, you're probably talking about, 6, 7, 8 months to get that kind of capability spread across the entire line. And in parallel, your digital twin capability is being built up and deployed. That's going to sit on top of your chosen sensing technologies. And again, that stream can also take a comparative amount of time, but those kinds of things happen in parallel. So what we see is small projects are completed in 3 months. This is a couple of line segments or 10, 20 different workstations, and whole assembly lines we're doing in something like 6, 7 months. So it's not long before you've got time to value with these capabilities.
We've also got a follow-up on sensing technologies, which you mentioned there. And someone's asking about how you know what sensing technologies to select to solve these challenges.
Yeah, that's absolutely a great question. So that feeds into that whole notion that there's no one perfect sensor for the job, right? And as I say, UBSense, we've been doing this as a business for a long time. And what companies out there need to find is what we try to be for our customers is a trusted advisor, a partner, if you like, in deploying these kinds of capabilities into their plants. Because you need to understand the performance characteristics of the technologies that you have on offer. And you need to be able to work closely with customers to understand the details of the problem that they're trying to solve. And that means that there are going to be certain technologies that work well and certain technologies that are just not the right choice to solve those problems. And because we, as a company, one, we work as a trusted advisor to our customers, but we also, through our own digital twin capabilities, we have relationships with many of the best vendors in the market for the spectrum of technologies. So we understand the performance characteristics of those technologies, and we can help point our customers to say, these are the options that you have in front of you. And these are the cost benefits of choosing technology A versus technology B, and also the performance differences. And so we help customers to make an informed decision around technology investment, but also, reducing the chance that they're going to be, again, locking themselves into one specific technology.
One listener writes, it seems that the infrastructure using digital twin is not using any PLCs. Is this true? Is that something you can clarify? So
there's not a dependency on PLCs. So this kind of capability that we're talking about today, we're talking about a centralized, server-based architecture that can be on-premise or that can be hosted in the cloud. But these technologies and the digital twin capability absolutely integrates with your PLC landscape as well. So we have many customers that are both using the control signals out of the digital twin to go up to things like the MES and the ERP, but we're also feeding those signals down to PLCs as well to do those kinds of shop floor level control messages.
Another question, are all the capabilities you've described required, or can I augment existing technologies I've already invested in?
Yeah, absolutely. So that's similar to the PLC question, actually. So the whole idea behind a digital twin capability like this is, you may have already made significant investments in, key parts of your production system and your production process. And what you're looking to do is fill some of the gaps. And that's a really kind of key way that we see ourselves engaging with customers. We're not coming in to try and supplant various systems and investments that you've already put in place, but we're trying to help the existing landscape be more effective, to get more value out of the data that you've already got in your organization. So the digital twin that you choose and the capabilities you choose should absolutely fit into your existing production landscape, and you should only take the bits that you need, not wholesale replacement.
And have you any advice for someone who might be, completely new to this? Sort of any comments on, how daunting a change it might be? Basically, someone coming completely new to this, what might you say to them?
So absolutely. So this is a journey. So as I say, we've been working with some of the biggest OEMs in the industry for many years, and companies don't change overnight. And it's about finding again a trusted partner that understands how to bring these technologies to life, and going on a journey and starting with one or a small number of specific use cases where you've got an immediate problem, and helping your business to see the benefits that these technologies can deliver. It's almost impossible to consider some kind of a large wholesale change. So starting small, starting with a specific problem that you can demonstrate value is a really key part of the journey. And then really it's about bringing the business along for the journey, educating internally, and we help our customers on a daily basis to do that kind of internal education, but also empowering our customers to go and have those conversations themselves, helping them understand the art of the possible. And as soon as you start to understand those basic building blocks that we talked about before, you start to see the way that you operate in a new light, and you start to see actually, for process A, process B, process C, there are gaps in the way that we implement those processes that we never knew that we could actually fill those gaps before. And this is one of those technologies that comes in, as I say, it fills in a lot of gaps for customers. So I think, in summary, don't be daunted by, the magnitude of change in the organization. Find the starting problem, address that starting problem, and then get your organization onto a roadmap for adoption over time.
Now, earlier in your presentation, you'd had a slide that had some pretty impressive names in the automotive industry. Can you share any case studies or takeaways you've had from projects with these big players?
Yeah, absolutely. So, I mean, as I say, we've been working with these technologies since 2008. So, we work very closely with the large German OEMs, Daimler, BMW, Volkswagen, and they implement these technologies across their assembly lines for real-time tool control, for example. And that's everything from doing digital tether capabilities like we talked about on the slides today, to everything from more sophisticated real-time control of those tools for adapting to the change in torque settings and batch sizes and things like that in real time. And when we talk about real time, we're talking about sub-second latency here. So operators can literally be moving between areas around the vehicle, different sides of the vehicle, between workstations, and all of that control is happening in true real time. And so those capabilities are widely deployed across the lines. And we see, again, the same OEMs and many others are also starting to move towards things like online rework. So when you used to have tethered tooling, which wasn't able to move outside of a workstation, everything had to be very station bound. But actually, now that you've got cordless tooling, you can move anywhere with it. And now if you've got a system that has eyes and ears on exactly what people are doing with those tools on the shop floor at any point in time, you can be assured that the only thing that they're doing with those tools is some kind of planned process execution. And so online rework is a really kind of key output of that kind of capability, that you can actually roam them up and down the line and do rework on products before they come off the line into a finishing area, which is a significant cost reduction, because doing rework on the line can save you, it's about a 30% of the cost of doing rework in a finishing and rework department.
Now, John, during your time with UBSense, can you talk to, I suppose, the prevailing attitudes that you've seen among manufacturers, their willingness to invest, their interest in modernizing? Has that changed? What's the feeling that you're getting from players out there today?
Yeah, absolutely. So there's a real groundswell of activity going on in this space right now. So as I say, we've been doing this for quite a long time now. These technologies are well proven. But I think that Industry 4.0, if we call that as an umbrella for all of these capabilities, many customers have been experimenting for the last few years, running lighthouse projects to try and understand the art of the possible. And I think it's starting to become clear, which are the capabilities that make the most sense. And so we are certainly seeing, both in the automotive sector, but as well as in the other sectors that we work across aerospace and agricultural machinery, the big high-value discrete manufacturing sectors, these technologies that we talked about today are the ones that many of them are starting to turn to really, get the most out of their Industry 4.0 strategy. And, there are a lot of different, levers that you can pull in implementing your Industry 4.0 strategy. But a key part when you're working in those discrete sectors is the dependency on humans and people to actually complete those manual processes. And when you've got people, that means you've got movement, you've got interactions, and the only way that you can gather that kind of data is by implementing this kind of a digital twin capability. So we're seeing a big uptick in demand for these capabilities, and the investment that's going into EV at the moment is another big catalyst, if you like, for customers to start thinking, how do I do things differently? So that's, we see this as a very exciting time.
And the approaches that you described as part of the digital twin and the move towards the smart factory, I mean, do you see this as an essential piece in realizing the smart factory of the future? And if so, what other elements are needed to complete the picture?
Yeah, absolutely. So we see this as a vital component, as I say, for those kinds of customers that are working on discrete products, where again there's that dependency on people. It's an absolute necessity to have greater visibility and control over what is happening in those people-led processes. But it's not a standalone capability. It has to be part of an overall strategy. And so, we see if you move away from the big OEMs, we see into the smaller players and startups as well. There's a big focus on getting your MES strategy right, getting your ERP right. And so those are two really big or fundamental building blocks to making this whole new way of working come together. So MES is a really key component of that. Now, we talked about at the beginning today that digital twin has another kind of definition which sits more in the traditional IoT space. Mm-hmm. And IoT is another really key enabler to this, right? You don't want to just understand what's happening with all your moving processes. You do want to understand what's happening with your shop floor systems, your robots, and things like that. So what you want to do is put a system like what you've seen from UBSense today alongside your IoT platform strategy. And both of those need to tightly integrate with your ERP and your MES. So it's a tightly integrated ecosystem of systems that's just going to really allow customers to get the most out of these new approaches.
Super. And I think we've managed to get through all the questions that have come through. So with that, I would like to bring this webinar to a close. I'd like to thank John for sharing insight with us today and UBSense for helping to make the event possible. Thank you for listening, and goodbye.